Today, we're going to be taking a look at the difference between discrete and continuous variables within statistics with the help of Python. Now, this is an important concept to grasp because this impacts some of the different distributions you take a look at, as well as the probability distribution functions. With Python, we're going to be using 3 different libraries today: NumPy, Matplotlib, as well as Seaborn. But before I jump into some Python coding and show you guys some examples, I want to go over a little bit more information about essentially what is a discrete variable and what is a continuous variable, how you can spot the differences. All right, so let's go over some information about discrete versus continuous before we jump into some code. So first, discrete numbers are countable and distinct. They can take on only specific separate values. So think of like an integer, right? So a few examples: number of runners in a race, right? You can't have a partial runner. Like on an ultra marathon side of things, you might have 150 runners in a race. When you go to a marathon, you might have up to 20,000 runners in a race, right? Whole integer numbers. Now, another example, I collect a lot of sports and non-sports cards. So imagine you're a baseball card collector, right? You could have 500 cards. You could have 1,100 cards. You could have 5 cards. You can't have a partial amount of cards. Another example, YouTube videos, right? My channel over here, we're about to reach 200 videos. That is a discrete value. 400 videos, which is on my card channel. I have more than 400, but let's assume it's 400. Again, a discrete value. These are all integers, right? And you can't have partials, and that is why it's discrete. So let's take a look at continuous. So continuous numbers can take on any value within a given range. They are measurable, not countable. Continuous data often arises from measurements. So this is where you go to decimal values. So here are some examples, right? Miles ran. So there's a lot of different distances in racing. Now, I never did track, so I'm not going to give you guys track examples. Instead, right, a 5K is 3.1 miles. A marathon is 26.2 miles. And there's a race that I'll be running later this year, which is 100 miles, right? You could have someone that runs a third of a mile. You could have someone that runs 50.5 miles, right? You could run any specific distance and you're always going to have a decimal value as part of it. Another example is weight, right? High school, I was 260 pounds. And then when I got into my best shape, I was 165 pounds. Right now, I'm still a little bit overweight at 191.2 pounds. That's what I weighed myself this morning. But regardless, right, weight is another classic example of continuous. So in this video, we're going to be taking a look at 2 examples in Python, and we're going to be plotting them out. So the first one is dice values. So you can think of a 6-sided die, right? The values 1 through 6. Another example over here is height measurement, right? Heights are all over the place. And dice values, uniform distribution because they're across the same. And our height is going to be a normal distribution. So we'll be jumping into both of these in this video, and let's start coding in Python. All right, so let's get started. What we're going to do first is we're going to import a few libraries. So import NumPy as np, import matplotlib.pyplot plt, and then I think we use Seaborn, so import Seaborn as SNS. Awesome. And let's get started. What we're going to also want to do is set up a random seed, so that way you guys can duplicate the results. So np.random.seed and 55. And we'll put that in there, and let's get started. So let's take a look at example 1. And this is going to be populating some discrete data. So probably one of the most popular discrete data that is out there for tutorial purposes is dice rolls. So instead of discrete, I'm going to call this dice rolls. Dice rolls, because it's pretty easy and simple and straight to the point. So dice rolls equals, and what we're going to do is np.random.randint. And all you have to do in here is your starting point, right? A dice starts with 1, and then your endpoint plus 1. So I'm going to say 7, because in Python, this 7 will not be printed out. It'll go up to 7, and since we're stopping at it, it'll look through 1 through 6. Next, what you want to do is you want to set a size. I'm just going to say size equals 500 over here. And now we have all of our dice rolls. And you can see that this over here is discrete because, right, all integers. There's nothing in between. You have either 1, 2, 3, 4, or 5, 6. So let's take a look at the opposite side. And we'll go to example 2, which is continuous. And I'll show you how to populate some data with that. Continuous, like that. And what we're going to do is we're going to set up different heights. So we're going to say heights equals np.random. And I'm going to look at a normal distribution. So normal like this. Now, log is where the mean is. I'll say 5.5. Scale equals 0.5, which is our standard deviation. And then again, we'll set a size of 500 like that. And now you're going to see a continuous example. Because if I go over here and I print out continuous, right, you can see we have 5.28, 5.12, 4.45, 5.77, 6.25, all of these over here, right, are discrete. Above, there's cutoffs. It's all integers. Down below, right, we have decimal float numbers, right, decimal place right there. We have a lot of stuff here after. They're continuous. So let's plot these out as well. And what I'll do over here is we're going to say example 3/4. I'm just going to plot these together and let's do that. So we're going to say is fig axes equal plt.subplots go 1, 2, and then fig size equals 14.6. That's all right. I shouldn't have pressed that button. That's okay. We'll repopulate all the code. So let's start off with our discrete, right? So we'll say discrete, and these are going to be both histograms, but that's all right. So we're going to say sns.histplot. We'll start off with our dice rolls. I believe I just called it dice rolls. I did. So we'll have dice rolls over here. Set our bins. So bins equals np.arrange, and we'll go from 0.5, 7.5, and then we'll say 1. There's a few different ways that we can set up our bins. I'll just do it like this for this video, and we'll see it throughout the other videos in the statistics series. Ax, we'll say axes 0. Then next we'll say KDE equals false. Since this is going to be a uniform distribution, we don't need a KDE. You'll see we'll need a KDE for our normal. Well, we don't necessarily need it, but it's nice to have. And we'll say color equals blue. And KDE is kind of just a line on the outside. And then we'll say axes 0 dot set title. Say discrete data dice. Do a few others. We'll set X label. We'll set our Y label like that. Dice value. And then frequency. That's. Then I'm literally just going to copy this code, and we're going to do our continuous data points. Right. So instead of dice rolls this time, we're going up here and we're grabbing all these different heights. And we're going to not use bins. We'll have a KDE equal to true. We're actually going to go over here. Forgot this. Say axes 1 over there. And then we'll change the color. We'll say green. Then set all these to 1 like that. And we'll say continuous data height. Yes. Data height. And then instead of dice value, what we're going to have over here for our X label, we'll have our height, and then we'll do density. That's awesome. And then what we'll do next is set up a plt.type layout. and then plt.show. And hopefully I had no bugs over here. Great. So you can see the dice values over here, right? 1 through 6. There's 500 of these. And it's a uniform distribution, although it's not perfect, right? But over time, the law of large numbers, we should expect all these to equal out. And then we have a normal distribution over here with these heights. You can look where 5.5 is, right? In the center. It's almost symmetrical. It's not perfect, right? We do have this really short person as an outlier right over there. But yeah, this was discrete versus continuous. Just very basic example, right? We're going to be covering a lot more topics in this statistics series, but remember, just for discrete, think of integers, right? Things that can't have decimal. And when you think of continuous, think of something that's like a decimal where you could have partial part of it. I think of dice and heights are the most clear examples that get taught all the time. But I also showed you a few other examples a little bit earlier, right? If you think about like a runner, you can run any amount of distance, right? That's going to be something that's continuous, where if you go into a race, you're going to have a discrete number of people. Hopefully this video cleared up any confusion that you had with discrete and continuous variables. And if it did, make sure to subscribe to the channel. We're uploading at least 3 different data science focused videos every single week, because it's one of our goals to hit 100,000 subscribers in 2025. Now, if you want to learn even more about statistics, I have a few videos as well as a playlist linked down below that I think you should check out next, as well right over here.